Of getting an F. So in this chart, in general, 30 English students, 28 math students. So this is the frequency, right? The number of students, everybody. And then 31 science students, 30 PE students. So everybody have a calculator out so we can fly through this. So then these are the number of people, the number of Fs each class produced. So I said, what's the probability of getting an F? So probability is the total of favorable outcomes divided by the total number of outcomes, right? Favorable means what we're looking at. So how many Fs total? So first of all, let's figure out what is the total number of students here. Would we add up the 4s, 5s, 3s, and 2s for that? No, right? We wouldn't? Okay, so what's the total number of students? Okay, so our total is 119. How many Fs did we get? 4 plus 5 plus 3 plus 2.
14.
Okay, 14 over 19. That is the probability, right? 119, sorry. 14 over 119. They might write it as a fraction because that is the probability. However, oftentimes they could write it as a decimal or as a percent. You type in 14 divided by 119, you get 0.12. That is also a probability, which is 12% as a percent. Does everybody understand? Okay. Next problem. Oh. Okay, we've got to remember, and you will want to write this down for yourself really quick. There's a difference between and versus or, and then or with overlapping events, and I'll get into more detail on that. So if I say find the probability of A and B, of this event and this event, and they're independent, meaning they have no effect on each other, like rolling a dice and a deck of cards. They have any effect on each other. So they're independent events. So if I tell you what's the probability of this and this, you just multiply the individual probabilities, right?
Yeah.
Okay. Now if I said find the probability of this or this, you don't multiply the individual probabilities, you will add the individual probabilities. And then if we're dealing with or, we still add the probabilities, but if you have an overlapping event, now let me give you an example. If I said to you, on a number cube, okay, everyone listen so you know what an overlapping event is. If I said, what's the probability of getting a 2 or an even? Isn't 2 also even?
Yeah.
So that overlaps. So you do the probability of 2, you do the probability of B, which is evens, and then you subtract off the overlapping events, because you're not going to double dip, right? Isn't 2 also even? So that's why we subtract off the intersection of those, which that upside down, U, just means and. Remember, that means and. So this and could be a probability of A and B, and then or is a U, A union B. So we subtract off where they are both. Does that make sense? A and B. Okay, so you have those written down. Okay, so let's read this problem. It says, what's the probability of rolling an even on a number cube and randomly drawing a card from a deck of cards and getting a face card? Keywords and, right? We don't have overlapping events here because rolling a dice and deck of cards are two totally different things, right? Everyone? Are we all paying attention? Okay, so let's find the probability of event A. Isn't that the probability of rolling an even on a number cube? So how many times does that happen? A 2, a 4, and a 6. 3 out of 6 times. Doesn't that happen 3 out of 6, everybody?
Yes.
Okay, so we found the probability of event A, 3 out of 6. Okay. Now the probability of event B says randomly drawing from a deck of cards and getting a face card. So how many face cards are in a deck of cards? First of all, how many total cards are in a deck of cards? 52. And then how many face cards? Remember there's 4 suits, right? Diamonds, hearts, clovers, clubs, right? So there's 16 because there's 4 face cards per suit. So that's 16 face cards.
Isn't a face card like a jack or something?
Oh, yeah. Or an ace, right? Yeah, good. So it's good to remember that. So now, because we're using and, don't we multiply the individual probabilities? So we do 3, 6 times by 16 over 52. Now they might leave their answer as, if they say leave it as a simplified fraction, then you do it as a fraction. If they say just what's the probability, you can usually do fractions, great. Let's just write down both. Here we go. So 3 times 16 divided by 6 times 52.
13.
Did we all get that? Yeah. Okay. So we got 2/13. That is the probability. What's also the decimal? Let's try to move both down. 2 divided by 13. Also would be 0.15, right? Which is 15%. There's a 15% chance of having both of these events happen at the same time with an and. Are we all good? Okay, next one. In this class, 13, so this is one that's actually really easy and some people tend to think too hard about it. In this class, 13% of this isn't true, but in this class, 13% of students are getting an F. In Ms. McCormick's class, 15% of students are getting an F. What's the probability a randomly selected student will have an F? So amongst the two classes, right? So isn't it just 15% plus 13%? They have nothing to do with each other, right? So isn't it this or this? So it would just be 13% plus 15%. There's a 28% chance, right?
That's a lot.
What was that?
When you have to multiply something out.
This was or. What's the probability that she has an F or that a student has an F would be an F in her class or my class? Or means addition. So that's why we added. Does that make sense? Okay. This is one where you have to be really careful. This is where most people just royally screw it up. Okay? It says, what's the probability of rolling a 5 or less on a number cube or an odd on a number cube? So it's or, right? Now, if it overlaps, meaning both events overlap, then you need to use the right formula. So you said it's overlapping. So probability of event A is rolling a 5 on a 5 or less on a number cube. How many times does that happen? 5 out of 6, right? 5 out of 6? Everybody understand that? Okay, 5 out of 6 times. The probability of event B is rolling an odd on a number cube, which happens how many times?
3 out of 6.
3 out of 6, right? A 1, a 3, a 5. 3 out of 6. You're right. 3 out of 6, yeah, we could simplify it. I'm just going to leave it. And then because they overlap, we need to know where they overlap. So when does A intersect B? What's the probability of A intersecting B? So when does A intersect B? When it's 5 or less, right? And an odd. So when does that happen? Let's think about it. I'm going to write down. We could roll 1, 2, 3, 4, 5, or 6. So when is it 5 or less? Wouldn't that be these? And at the same time, because that's what this means, right? And at the same time, odd. 1, 2, 3 times, right?
Yeah.
So this is 3 out of 6, right? So now to find the probability of this or this happening, probability of A or B, we take probability of A plus probability of B minus the double dipping. Probability of A intersect B, and I can't fit that. So probability of A was 5, 6 plus 3, 6, right? Are we all following? Minus the double dipping, which was 3, 6. Now this one happened to be the same. They don't always cancel out exactly. Does that make sense, everybody? Or else the formula would not be necessary. Okay, so what's our final probability? 5, 6. Next one. What's the probability of rolling a 2 on a number cube or an even on a number cube? Also overlapping, right? So let's do probability of A. What's the probability of rolling a 2 on a number cube? What? 1 out of 6. Probability of rolling an even?
3 out of 6.
3 out of 6. Now, 2 and even, right? What's the probability of A intersect B? 2 and even. How many times does that happen?
1 out of 6.
1 out of 6. So we know they're overlapping. So we do the probability of event A plus the probability of event B minus the double dipping, the overlapping. So our final answer is 3, 6, which is 1/2, right? Questions? This one is the one that a lot of people really miss. So please pay attention to this one, if any. Okay, conditional probability. So it says probability that a person likes vanilla and cupcakes. So like if I just said to you, I took a poll for an upcoming event to see what kind of dessert to do. So 6 people said vanilla and cupcake. Does everybody understand how the chart works? Finding the probabilities is the important part. So what's the probability that a person likes vanilla and cupcakes? Isn't and the intersection? So vanilla and at the same time cupcakes was 6 out of how many? Add them up. What is it? Yes. So there's a 6 out of 29 probability, right? That they chose vanilla and cupcake. Okay, moving on. Here's the hard one, okay? But it's not hard, so pay attention. Probability that a person liked chocolate given that they picked cookies. So now this is conditional. We're starting with given that they picked a cookie, right? Isn't that what we're looking at? So we're only looking at given they picked a cookie. Now what's the probability that they liked chocolate?
2 out of 6.
2 out of 6. Does everybody understand that? Way to go, Master. 2 out of 6. Very good. So let's erase that. Let's start here. The given ones, people just screw them up. Probability that a person picked a cupcake given they liked chocolate. So I'm starting with the given. So given they liked chocolate, what's the probability they picked a cupcake?
8 out of 14.
8 out of 14. Very good. Okay, and then it says, what's the probability a person picked cookies? Isn't that 6 out of the full thing?
29 out of 20.
Yeah, 6 out of 20. Very good. All right, we're awesome. Okay, last one. Oh, actually not last one. 2, this is 1. Okay, get your packet. Go. Get your packet.
Which one? We got 6 books.
The Sage Review packet.
Yeah, that one yesterday was so long. Didn't finish it all. Yeah,
We're working on it Monday and Tuesday of next week. Okay? So we can, yeah. Okay, so Braylon caught this.
No, I caught it. I did.
Oh. Okay, you guys both caught it, thankfully. So here was my mistake, guys. Here's my mistake, okay? And I royally kind of screwed this one up. That's okay, that's how we learn. So it says, the person can see the top of a building at an angle of 65 degrees. Now it did not say angle of elevation, right?
Right.
Now here, that's the catch. Angle of elevation from the ground up, but it did not say angle of elevation. So I had said, oh, they gave you some extra information here, but they didn't. So it says the person standing 50 feet away from the building and has an eye level of 5 feet, how tall is the building? So we've got to draw our picture correctly here. So we have our person, let's draw our picture real quick.
What's that?
We have our person,
Santa.
it's 50 feet away from a building, right?
It's Santa.
Why does that bug you so much? That's a leash, he's walking a dog. Okay? Alright. So it says, the person's 50 feet away from the building. Now here's the catch. From the building, he has an eye level of 5 feet. So his eyes are looking across out that 5 feet, right? Everybody?
Yeah.
Now because it doesn't say the angle of depression, which is from the ground up, it just says the person can see the top of the building at an angle of 65. So didn't their eyesight start right here at 5 and go up at 65 degrees? So this is our right triangle up here. So if we find x, aren't we only going to be finding the distance from here to here to the 5 feet? Right? So let's go through and solve for x. Because if this is 50, this is still 50 feet. So we still do opposite and adjacent tangent. We solve for x, we get x is equal to 107.3?
2.
Okay, 107.2. Is that true? Yeah, that is true. Isn't that x?
Oh, yeah.
But now we've got to answer the question correctly. This one was kind of tricky. So it said, how tall is the building? So don't we need to consider that also that extra 5 feet?
Yep.
Okay.
Add 5.
So add 5, so that's 112.2. So just fix your answer if you got it wrong. Good job on catching that, Braylon.
Oh, my.
And
That
Maxa.
was me, bro. No, who was it?
All right. Next one.
No, it wasn't you two.
Okay, conditional probability. You know how we just did it with a chart? Everybody listen so that you know the difference. This is hard. This is the hardest one by far. Okay, conditional probability. We just did a bunch of conditional probability, right? This given this, right, everybody? But that was given the numbers and in a chart. So it's very different. You've got to use the formula if you're given probabilities. So back here, if you were given a chart, we were able to calculate the numbers and actually just calculate the probability. But this one's different because we're going to be given probability and have to find the probability of conditional events. So this says, this is how this formula works. It says, this is how you find the probability of B given, the slash means given, that event A has already happened. Does everybody understand that? The probability of event B, are you listening? Because you people need to listen. The probability, yes, you. Don't look behind you, it's you. Probability of event B, given that A has already happened, you'll do the probability of A intersect B. Now think about it. Isn't A intersect B the probability of A times B?
Yep.
Divided by probability of A. Is everybody comfortable with
How
that?
come the probability of A just doesn't cancel out then? Yeah.
Because this is connected. Like you gotta You'll see. Yeah, it's grouped.
Okay.
Yeah, no,
Okay,
it's
okay.
good questions. Okay, so number one, I'm going to do this one with you. It's hard. Because people jump to conclusions and do some bad things. It says, what's the probability? Oh, let's read the problem first.
Oh.
I didn't write down the problem. Make sure you're on the page reading it with me so that it makes sense to you. Here we go. Oh,
What's the
freaking A.
probability that someone who did not
Okay, nope. I'm going to read it. Thanks for trying, though. Here we go. So we're reading it. It says, a physician determines that on average 40% of his patients get the flu each year. Of this group, 10% receive the flu vaccine. Of patients who did not get the flu, 20% receive the flu vaccine. Use the information to answer 1 and 2. So this is, we've got to actually, that's all jumbly. We've got to draw ourselves kind of like a diagram here. So a physician determined on average 40% of his patients got the flu each year. So I'm going to write that. 40% got flu. You guys should write this down. Is that true? So then it does not tell us, but what do we know? How many did not get the flu? What percent?
60.
60% didn't get flu. Okay. Is everybody good with that?
Yeah.
Okay, so then moving on. It says, of the group that got the flu, 10% received the flu vaccine. So of the ones that got the flu, 10% got vaccinated. So then what percent of this group did not?
30.
No.
Oh, 90.
90% did not get vaccinated of this group, right, people? 90% did not.
The other people speak.
No.
Dude, vaccine.
Okay, so keep reading. It says, of the patients who got the flu, 20%. What? Oh yeah, right here. Of patients who did not get the flu, 20% received flu vaccines. So of the people who didn't get the flu, 20% did get vaccinated, right?
Got back.
So then what percent of this group did not?
80.
80% did not, okay? Now you have to draw this out, because if I say, now you'll see what I mean. Okay, so now let's read problem number 1. It says, what is the probability that someone who did not receive the vaccine got the flu? So isn't this conditional? It's saying, if this, then what's the probability, right? Everybody, that's conditional. So let's figure out what's the condition. So what's the probability they got the flu?
So 40.
Given, wait, we gotta be careful. Let's be careful. Given that, what? They did not receive the vaccine, right? Isn't that what we're finding?
So how would you do that?
I'm gonna show you. Okay, I'm gonna show you. Didn't receive vaccine. Okay, so this is event B. Look at this is B, given that A has already happened, right? So this is event B, this is event A, okay? So let's be really careful. Let's find the probability of event B all by itself. What's the probability that they got the flu? 40%.
Oh,
Stop.
you didn't get your vaccine.
Yes, I did. We're required.
Your mom.
Hey, we're required to.
You know your mom's sick.
I'm having a heat stroke over here. I'm gonna have a coughing attack. Okay, well we're actually wrong. Isn't there 2 times that they got the flu? They got the flu and vaccinated, got the flu, didn't, right?
Yeah.
So that's where people mess this one up royally. So there is a 40% chance. Okay, so to find that probability that they got the flu happened in 0.40 times 0.10, right?
Yep.
Plus 0.40 times 0.9. Calculate that. That's what it's really. Because there's 2 circumstances where they got the flu. The 0.40 times 0.10, probability of those 2 things happening, right? Plus the probability of those 2 things happening. So what's the probability of B?
17.
Point what? You're just guessing. Don't say anything unless you calculate
I'm
it.
pretty sure.
Nope. What is it? Okay, 0.04. So now let's find the probability of event A happening. Wasn't that did not receive vaccine?
But
Yeah?
they got the flu, right?
Okay, there's 2 times they didn't receive the vaccine. No, see, no, that's where people mess it up. Right now we're just doing A, not given B, right? Isn't this just A?
Oh,
So did not get the vaccine. So what 2 times did that happen? Right here and right here, right? Didn't. Okay, so go. Calculate that probability. There's 2 times they did not receive the vaccine. Either they got the flu and didn't, So you do 0.40 times 0.90 times 0.90 plus, there's another time they could get the flu, 0.60 times 0.8.
0.84.
What do you get? 0.84. Okay, good. Now, our last step is to find the probability of A, B, given that A has, or B intersects A. Right? B intersect A? So isn't that and? Where they got flu and did not receive vaccine. So got flu, independent event, 0.40, and did not get vaccine. Does everybody understand why this and comes in?
Yeah.
And is the and means the intersection, right? Are you listening?
Yes.
So now I'm finding the intersection of both. They got the flu and at the same time didn't receive the vaccine. Don't you multiply individual probabilities for and?
0.4.
So 0.4 times 0.9, right?
Yeah.
Yeah.
0.4 times 0.9.
Yeah. Blowing, keep blowing.
What do you get?
Keep blowing.
0.36. So now we'll do the formula, which was the intersection divided probability of A. So the intersection was 0.36 times by A, which was 0.84. Points, what? 3? No. Are you sure?
0.42857.8.
Okay, when you did that, we got what?
4.43.
Oh, shoot.
0.43. Very good. Do you see how when it's dealing with probabilities, it's a lot harder to calculate than just looking at the chart? Yeah, okay.
This is tough.
Well, you can do it. And I'll leave this up. So finish the packet. Work on probability.
30 minutes to do one.
How fast?
No, did not. And I just did one with you.
Oh,
Go.
doodles.
What?
Me neither.
Then your guys' back page fell off in your thing somewhere.
I don't have the first three.
I have a page 3.
Take it wrong, take it wrong.
I have page 3.
Yeah, so do I. We both have 3 and 7.
Nope.
I know my front page fell off. I don't know how that.
I don't buy it. It was all there at one point.
This is a key dog.
Isn't it theta over 360? So arc AC over 360? Isn't theta arc AC? So theta, yeah, AC over 360, and then pi r squared. Radius squared is 5 squared, which is 25.
Oh, yeah, so I just used. No, but it has to be 5.
No, radius squared. That's how 5 squared is? 25 is.
Okay, I found my first 2 pages.
And this one. I didn't know how.
Yeah, that was the first stop.
When you hit page,
Okay, then work on probability and then come back to that. All probabilities fresh.
actually,
I work on probability while it's fresh in your head.
Take it wrong, take it wrong, take it wrong. Keep blowing, keep blowing, keep blowing.